Happy Monday, everyone. Hope that you're having a good day so far and that it continues. So, on Friday, homecoming day, we spent the time going over the homework that we did for all of this type of factoring. Remember all this? GCF, difference of squares, and sum and difference of cubes. I think that y'all are in pretty good shape. So, today we're going to continue on and we're going to do these type. We're going to do trinomials, which we've already done, so we don't have to spend that much time on this. But then also, we're going to move into another worksheet, and if that hasn't gotten to you, the sub will hand that out now. And what you do in this one is factoring when you have four terms using this method called grouping. It's actually one of my favorite methods of factoring. It's one of those weird ones. You actually have to factor it before you realize whether or not it could even be factored, which I'll explain later because that sounds weird. But anyways, we're going to go ahead and get started on this. Let me give you a quick breakdown of the week, though. Tomorrow, we're going to spend a little bit of time going over this homework assignment, making sure you guys understood everything. And then I'm going to give you guys a review for your second test for this 9 weeks. It's only 2. Again, I have your test graded from the last one. I just have forgotten to enter it. I promise you it will be entered before I come back to class on Tuesday. I hope to do it while I'm out of the district tournament tomorrow, but if not, I promise you it will be done before I return to class. Anyways, I want to give you guys plenty of time to get prepared and to do well in this test. So you're going to get the review on Tuesday. We'll talk about a few of the problems then. And then on Wednesday, we'll come in and we'll finish it up. And then, so I'm going to go through every problem on that review on Tuesday and Wednesday. And then you're going to take your test on Thursday. Now, I know that Friday is the day right before fall break. So what that day is going to be left for is 2 different things. One, if anybody didn't happen to quite finish the test, they'll have time to do that. Hopefully everyone will finish it though, and we'll be able to use that time on Friday in class to actually do some corrections. So anyways, we'll talk more about that because I will be returning tomorrow and I'll be here for the rest of the week instead. Or in actuality, this is the last day I'll be missing for golf. So that's good. It's been a good season, been fast, and I know I've missed a lot, and I apologize. But this is it. This is the last day for golf. So you'll be seeing me obviously a lot more. Anyways, let's go ahead and go back to your memory banks when we used to factor trinomials. Remember, these are the ones that we learned how to factor into 2 binomials. Remember that? And it's kind of like a little puzzle piece that we do where we figure out what multiplies to get this ax squared value here. Then the sign here we determine based on what's multiplying to get that positive. And then these last 2 values we do, let me do the designation a little differently. These last 2 values we determine based on what multiplies to get this, but they combine to get that. And y'all have done fairly well with this in the past, but that's what we're moving back into today for a brief moment. So here we go. Let's do down the right side. We'll just hit some of these. We're not going to hit all of them, but we'll hit some of these on our way through. So again, look at this. Always ask, is there a greatest common factor? Nothing comes out of n squared, 7n, and 30. So we're ready to roll. We're ready to break this down into 2 binomials. So what multiplies by itself to get n squared? N times n. What multiplies by itself to get a negative? Plus and a minus. So therefore, the last thing is we're trying to determine the 2 values that will multiply to get 30, but have a difference of 7. Multiplies to get 30 has a difference of 7. Well, it's got to be 10 and 3, y'all. It's got to be 10 and 3. 10 times 3 is 30. The difference between 10 and 3 is 7. So the last thing is this. What sign dominates the middle? Positive does. So positive has to go with my bigger factor. So it's n plus 10 and n minus 3. Y'all remember this, don't you? I'd say that you probably will catch right back up pretty quickly. Again, the fun thing with these is it's kind of like a little puzzle, and you're just kind of putting it together, piecing it together. So let's skip a couple because we don't have to do a ton of these. Let's go down here to number 28. Again, don't forget, you always need to check to see, is there a GCF? Is there a greatest common factor? See, we're not just dealing with quadratics anymore. We're dealing this time with a cubic function. So, I guess a cubic expression, there's no equal sign. So look, I can definitely, they're all even. I can definitely pull out a 2. And this has a cubed, this has a squared, this has a. I can pull out a 2a. So let's see what that leaves me with. 2 divided by 2 cancels 1. A cubed divided by a is a squared, so a squared. Positive 38 divided by 2 is positive 19. And a squared divided by a is just a. And lastly, 68 divided by 2 right here is 34. And then a divided by a cancels. Okay? So we've pulled out 2a. Now listen, now because this is not just a quadratic, but it's a cubic function, this factor right here, it's important because it has a variable. So hold on to it. Don't let it disappear. But now we're going to factor this trinomial into 2 binomials. Here we go. What multiplies by itself to get a squared? A times a. What multiplies to get this positive right here? Well, they both have to be positive because that middle term right here is positive. So they both have to be positive. And then lastly, because those signs are the same, we're looking for the two numbers that multiply to get 34 combined to get 19. It's pretty easy, really, if you start just typing some stuff in. It's 17 and 2. 17 times 2 is 34, and 17 and 2 combined to get 19. Again, because these signs are the same, it really doesn't matter where I put them. So my factors are 2a, a plus 17, and a plus 2. Okay? Pretty easy, right? Now let's look at number 30. Number 30. Very similar to that one. You need to pull out a GCF. There's no number. Look, that's a 1. You can't pull a 1 out. That doesn't really help me. But you can pull an x out. Look, they all have at least x. So I'm going to pull an x out. And that leaves me with x to the fourth minus 24x to the second, right? X cubed divided by x, 1 goes away, minus 25. Now, the reason I wanted to show you this one, because it's not overly difficult, is because even though it's not a quadratic anymore, look, it's not a squared, a to the first, and then no a. It's x to the fourth, x squared, and then no x. It's in the same form. Look, what multiplies to get x to the fourth? X squared times x squared. See, it combines to get x squared. See, you can factor these the same way because they fit in that same form. Okay, 2, 1, 0, or 4, 2, 0, or 6, 3, 0. They all work the same way. So we're going to try to factor this into 2 binomials. So here we go. X squared, x squared. To multiply to get a negative, positive, and negative. And then, of course, also, we're looking, because those signs are opposite, for the two numbers that multiply to get 25 have a gap of 24, a difference of 24. Well, that's definitely 1 and 25. A lot of times we forget about those real easy ones. Now, again, look in the middle. What sign dominates? Negative. Negative has to go with my bigger number, and that, of course, is 25. And then, of course, here, my 1. Now, I got kind of quiet for a second there because I realized I had screwed up on something. So I'm going to kind of make mine a little smaller because don't forget, and we kind of run into this the other day, don't forget, you got to check these factors and see if they're done. Like, is this one done? Yeah, Yeah, I can't do anything with x. Is this one done? Well, yeah, that's a square. But this is not a difference of squares, so that one's definitely done. But if you look at the next one, is it done? No, that's a perfect square, that's a perfect square, and that's a minus sign. So this is difference of squares, which will break down into two binomials. Remember what they are? X times x gives me x squared. 5 times 5 gives me 25. And then the rule is one's positive and one's negative. And now it's done. Now look, that's pretty intense. And that's the deal with these. This is what makes these hard. Because a lot of times you'll do the right thing and you'll get it to a certain point and then you stop and it can go further. Like this one did. This went further because it was difference of squares. So just be diligent to check that, okay? I'm going to skip 32 and come over here to 31 and do that one. Because, as you guys recall, and both 31 and 32 are both like this, you can't pull a GCF out. But this right here is not a 1. It's a 3. So we can't just easy factor it. So we go over, under. There's my over. Okay, we've done the over. Don't forget, we still got to do the under. So let's multiply that, and here's what we leave ourselves with. X squared minus 10x plus 24. So now we can easy factor it. What times what gives me x squared? X times x. What times what gives me this plus right here? Well, either both positive or both negative, so I look right here, definitely both negative. So we're looking for the two numbers that multiply to get 24, but combine, because signs are the same, combine to get 10. Well, hopefully it don't take you too long. 6 and 4. 6 times 4 is definitely 24. 6 and 4 definitely combine to get 10. So these both have to be 6 and 4. And the problem is a lot of people stop there. But you can't forget to come back under. We did the over, now we got to come back under. So we take those values and we divide them by 3. Now this one will simplify. 6 divided by 3 is 2. So this is simply x minus 2. This one will not reduce 4/3, so we move the 3 on the x and write 3x minus 4. And there you have it. We factored that trinomial. Okay? Hopefully you guys recall that. Let me do number 34 real quick. This will be the last one. Look, there's no GCF. This number is definitely not a 1, so I'm going to over under it. Okay? So m to the 4th minus 11m squared plus 24. So we're going to factor that easy style now. What multiplies by itself to get this m to the 4th? Well, that's m squared and m squared. And see how that matches this right here? It absolutely does. What multiplies to get a positive? Well, either both positive or both negative. So right here, both negative. So we're looking for the two numbers that multiply to get 24, combine to get 11. Multiply to get 24, combine to get 11. 8 and 3. So it's got to be 8 and 3. But don't forget, guys, we did the over. Now we got to do the under. So we divide those by 12. Now this one's a little bit harder because will 8 over 12 reduce? Yes, then let it. It's 2 over 3. So what do I write? 3m squared minus 2. 3 over 12 reduces to 1/4. So what is that? 4m squared minus 1. Now, again, the reason I wanted to do this problem in particular, because I don't think I'm positive that number 20 or 33 did not do this, but this one did. Look, 3m squared minus 2, that's done. Because neither 3m squared or 2 are perfect squares. But look at the next one, y'all. 4m squared is definitely a perfect square to m. 1 is definitely a perfect square, and that sign is definitely a minus sign. So this will factor using difference of squares into two binomials, 2m and 2m, 1 and 1, and the rule, one's positive, one's negative. And now it's completely factored. So factoring trinomials, this is something that you've done pretty recently, and therefore I expect you'll be just fine. Okay? Now, to my favorite type of factoring, I want you to notice two things that I want to stand out. One, these need to be in standard form. See x cubed, x squared, x the first, no x. They need to be in standard form, first and foremost. Secondly, I want you to notice that there's 1, 2, 3, 4 terms. There's only one method of factoring 4 terms, and it's called factoring by grouping, or factor by grouping. So what you're going to do is you're going to group the first 2 terms. Literally, you're going to just put your parentheses around it. And then you're going to group the last 2 terms. And then our job is to factor the GCF for each group. So look just first at this group only. What can I pull out of x cubed and x squared? Well, I can definitely pull out x squared. Now let's see what's left in there after I do that. X cubed divided by x squared is x. Positive x squared divided by positive x squared is positive 1. So inside that parentheses, when I pulled the GCF out, I was left with x plus 1. Now go to the second group. And here's the first rule I want you to remember. Whatever this sign is, if that's a minus or if it's a plus, whatever that sign is has to be the sign that you use. Now, what will come out of 4x and 4? Well, definitely 4. So we're going to pull out negative 4. So what is negative 4x divided by negative 4? Well, negative 4 divided by negative 4 cancels, and that leaves me with just x. And then finally, what's negative 4 divided by negative 4? Again, it cancels, but that means it cancels to a positive 1. Remember, negative divided by negative is positive. 4 divided by 4 is 1. So here's the deal. Remember earlier when I made a weird comment? I said, this is the only type that you actually have to factor, because we just factored it. It's the only kind that you have to factor before you realize whether it can even be factored. And here's how I can tell. When whatever is left in your binomials, whenever what's left is identical, I mean identical, has to be exactly the same. Whenever what you have left is identical, it could have been factored. And your factors are what you pulled out of both. Now, what did I pull out of this one? X squared. What did I pull out of this one? Minus 4. So there's one of your factors, and your other factor, only one, is what you pulled, or what was left inside common, x plus 1. Not x plus 1 squared, just x plus 1. So there you have it. That's factor by grouping. Now, don't forget, because of the nature of x squared and 4, they're both perfect squares, and that sign being a difference, that's difference of squares, which will break down into 2 binomials. X plus 1 is just going to drop down because it's done. But we got x times x to give me x squared. We got 2 times 2 to give me 4. We got positive and negative because that's the rule. Okay? So that's it, y'all. That's how you do factor by grouping. It's actually quite simple. I hope that you agree. So let me show you number 36. This has an important rule that you need to see. Again, notice, standard form, yup. 1, 2, 3, 4 terms, yup. Factor by grouping. Let's start with that first group. What can I pull out of k cubed and 5k squared? I can pull out a k squared. So let's see what that leaves me with. K cubed divided by k squared is k. And then what about positive 5k squared divided by k squared? Well, the k squareds will cancel and plus 5 drops down. Now remember what I said earlier? Whatever the sign is has to be the sign that you lead with here. And here's why I wanted to show you this one. Can I factor anything out of k and 5? No. But I can't just leave this negative here and then open up a parenthesis. Remember what's left right here when I do that? It's understood to be a negative 1. I can always pull a 1 out. Watch this. What's negative k divided by negative 1? Positive k. What's negative 5 divided by negative 1? Positive 5. And here's my question. Are the things left inside the binomials, are they the same? Well, absolutely they are. Then my two factors are what I pulled out and what was left inside. The only thing about what was left pulled out, that's k squared, that's a perfect square. That's 1, that's a perfect square. And that's a minus sign, that's difference of squares. So we break that down into two more binomials. Let k plus 5 just drop one down. K times k gives me k squared. 1 times 1 gives me 1, plus, minus, done. All right? Good time, right? I think you guys probably enjoy this. Let's do number 37. Again, look. 1 or 3, 2, 1, 0. It's in standard form. Also, 1, 2, 3, 4 terms. So factor by grouping. All right? So look at this. I'm going to pull v squared out of that first group. That's 4v minus 5. I'm going to start with whatever that sign is, so that's a minus. What can I pull out? 16 and 20? 4. I'm going to pull out a 4. Actually, I'm going to pull out a negative 4. What's negative 16v divided by negative 4? Well, the negatives will cancel, and 16 divided by 4 is 4v. Positive 20 divided by negative 4 is negative 5. So is what's left over the same? They're identical. So my two factors are what I pulled out, v squared minus 4, and what was left inside, 4v minus 5. Now hopefully you're starting to get the hang of this. V squared minus 5, or 4, that's difference of perfect squares. That will factor into two binomials. The 4v minus 5 just drops, but that's v times v, that's 2 times 2, that's plus and minus. Easy, easy. Last one I'll do is right here. I'm going to do number 40. Again, look, it's 4, 3, 1, 0. I know 2 gets skipped, guys, but is it in standard form? Absolutely. Then it's okay. Now, lastly, I know that there's 1, 2, 3, 4 terms, so sure enough, we're going to factor by grouping. So look at this first group. I definitely can't pull a number out. Look, that's 2 and 3. You can't pull anything out of those two. That's g to the fourth and g to the third. So we're going to pull out g to the third. So 2 divided by 1 is 2. G to the fourth divided by g to the third is g. So 2g. Negative 3 divided by 1 is negative 3. And g cubed divided by g cubed, gone. It's gone. Now remember what I said. Whatever this sign is, has to be what you lead with. It's a plus sign. What can we pull out of 16 and 24? Think. It's an 8. 8 will go into both. So we're pulling out a positive 8. You can't pull a variable out because 24 doesn't have one. But we can pull out 8. What's positive 16 divided by positive 8? Well, that's 2g. Comes down. Negative 24 divided by positive 8, negative 3. And, of course, is what's left inside identical? Yes, it is. So my factors are what I pulled out, g cubed plus 8, and what was left inside, 2g minus 3. Now, y'all going to hate me for this one. But look, that's a perfect cube. 8 is a perfect cube. So this is sum of cubes, which will break down into a binomial times a trinomial. Now, don't forget your 2g minus 3. It doesn't just disappear. It's still there. But here's my binomial. What multiplies by itself 3 times to get g cubed? G. What multiplies by itself 3 times to get 8? 2. So remember what we do with those on the edges? We square them. What's g times g? G squared. What's 2 times 2? 4. That's what we do on the edges. Now what do we do in the middle? We multiply them. G times 2, 2g. And then again, I like to do my signs at the end. If my original binomial is plus, so is this binomial, and this sign has to be negative to offset it. What do we say about that last term? Always positive. So there you have it. Factor by grouping. Some people love it. Some people deal with it. Some people hate it. We'll see where you are on the spectrum. So this video is about 26 problems. Or I'm sorry, what? These notes were about 26 minutes or so. So you're going to have a good solid 20 minutes to work on your homework. I expect you to be working. So here they are. On the homework page that you got last week that we checked on Friday, I want you to move past the ones that we did together the other day and go to 13, 15, 17, 19, and then whoa, hang on just a second. I can't let y'all see that. I don't even know why those answers are all there. So, goodness gracious, I hope. I almost ruined that. So I want you to do all of 4 of these factor by groupings, okay? So here it is one more time. It's 13, 15, 17, 19, 21, 22, 23, 24, 25. That's 9 problems, okay? That's not that bad. That's not that bad at all. 9 problems, 20 minutes, okay? I hope you guys have a great rest of your Monday. We will definitely go over these tomorrow before I give you your review. We'll go through some of that review tomorrow. We'll go through some of that review on Wednesday, and you'll take that test on Thursday. Be prepared. Talk to you soon.